Okay, let's see. A company makes candles in the shape of right circular cone, and we can see that each candle is made by pouring melted wax into a container. As it fills the container, the melted wax is always in the shape of a cone. This cone has a radius of r. We can see that. Its height h is the same as its diameter. So that's a crucial sentence. So what do I know about diameter? Once I see a word diameter really in my question, I think about that is 2 times r because diameter goes across and it's r and r. So that means that the height is 2r. Okay, so we have to show that the volume of the cone is given by. Okay, how do I get the volume of the cone? I go to the table, I find my formula for the volume of the cone. There it is. So we take that and we apply that to our situation at hand. So that means that is volume will equal 1/3 multiplied by pi multiplied by radius to the power of 2 multiply. I have h, but my answer doesn't have h. That's why they told me that h is twice the radius. Multiply by 2, multiply by r. So what can I multiply here? Well, 2 by 1/3, that is 2/3. And then pi to the power of 2 multiplied by, r to the power of 2 multiplied by r will give me r to the power of 3. Now, what happened here is that we have changed formula that is not a function into a function. It is a function with v being the y, volume, and x being the radius, because I have now only 2 letters in that formula. Since this is paper 1 and this what happened, then I know that most likely we're going to have calculus in the next part. And that's what we do. The volume of the cone of melted wax increases at the rate of 0.5 centimeters cubed per second. Now, in your question, in paper 1, usually paper 1, extremely rarely to show up in paper 2. I'm not saying it will not, but we can see what happened here, that we have a function and now they are giving me a value of a rate. What is the rate? Derivative. So they give me derivative. What kind of derivative? I'm going to break it down in a minute, but when they are giving me a value of derivative, that means this is chain rule, and the chain rule I'm going to build. That's what it is. Now, chain rule that I'm going to build has to do with three derivatives, right? So let's look at our table. Where is the chain rule? There it is. So chain rule have to do with 3 derivatives. So let's write it. Let me just not mix up what was the letters. Okay, that's the letters used here. Oh, that's a multiplication sign. And that's the way we're going to approach that. So now, so this is first, second, and third derivative. That I need to have, I need to identify so that I can create the chain rule. So they give me the first derivative. Now, what kind of derivative it is? So the measurement are the key. So centimeters cube, and then I have seconds. So what do we express in maths in those two values? So seconds, that's time. And cube, whether centimeters, meters, have to do with what? Volume. So that means that my derivative will be dv dt. Now, how do I know that that is like x? Time is always like x. So they are saying that this derivative, the value of it, is 0.5. Now, that is increasing, therefore it's a positive value. If that word was saying decreasing by the rate of 0.5, then we know it will be minus 0.5. Okay, now they are telling us which derivative we have to find. Find the rate at which radius of the cone, so it is r, of the melted wax is increased with respect to time. So then I'm looking at radius and time. And again, by default, you can always take that time is like x. So dr dt, I'm looking for it when radius is 4. When radius is 4. So that's the one I'm looking for. So now I need the third one. Yeah, because I need 1, 2, 3 derivatives. Now, this one here is a little bit obvious because it's the last one. However, let's not look at that is obvious. So how will I know in the question? So look at that. You have to consider this chain rule like a building blocks. So basically, let's get some blocks here. Fill color red. So I have du here, du here. So let's say 2 red blocks. Now let's get a different color, green one. So here I have dv and here I have dv, isn't it? And then let's get one more color for a block, dx. So here I have dx and dx. Do you see that? Each color is twice, each element is twice. So we have dv, we have dt element, then we have dr, and then we have dt. So what am I missing? I'm missing dv block and dr block, isn't it? Now, how do I get what I am missing in question? Well, there are a few ways of getting that. One of them is looking back at what we've done so far. And that's the reason why that first part happened, because here I have a function v of r. So that means dv dr derivative can be created. So that is my third element. So that's my one. That's the one I'm looking for. And that's the third one. Okay. Now, as you can see, one derivative is equal sign, the two are multiply. So how do I know which two are multiply? As you can observe from the colored blocks, those that have the same on the top and the bottom, those two derivatives will be multiply. So in our case, if you are looking at it, you can see this one have dr. Let's actually get maybe so that we can see that. So this one is the r and this one is the r. So those two will be multiply. So that means dv dt will equal dr dt multiply by dv dr. Yeah, you can see that two elements are here. Okay. Now, which one am I looking for? I'm looking for this one. So that means that I have to take what happened here with v? dv, sorry, something is malfunctioning. Dv dt has to be divided by this derivative, isn't it? dv dr. And that means I'm going to get dr dt. Okay, so let's sub the values in. So we have dv dt, they gave us that's a number. We don't have dv dr, we need to create that, isn't it? That's our function. Let's just take that so that we can create derivative of that. So that we can sub that in. So how will derivative look like? Well, those are numbers, they cross over, isn't it? Oh, something is happening with my pen today. 2 over 3 multiplied by pi. So what happened with 3? Goes in front. And that 2, that will be 2 because that's 3 minus 1, isn't it? Now here you can put all of that in the calculator, but what will happen here is that this 3 will simplify with this 3, and I'm going to be left with 2 pi r to the power of 2. So that will be my dv/dr. So dv/dt, they told me that's 0.5, and that will be divided by 2 pi r squared. And that's my dr dt. Now, we were not looking for the derivative itself. What we were looking for is the value of that derivative when radius is 4. So let's do that. Let's replace my radius with 4 divided by 2 multiplied by pi multiply by, not radius, 4 to the power of 2. Now make sure when you put that in the calculator, that's in the bracket so that we attain calculator that this is divided by all of that, not just 2. We press equal and we get 1/64 pi. That is our answer. And our answer, the terms and condition is give your answer in terms of pi. So that's what I'm saying. The chain rule is not difficult to build. One, to recognize, that's when they are giving you value of derivative, when they say the rate is and put a number. So that's the first part, knowing this is the chain rule I'm going to build. And that's how you approach it. You approach it as 6 blocks, 3 colors, 2 of each. That's it. That's how simple it is. Like giving it to a kindergarten and say, build that with those blocks, yeah? So that's what I'm saying. Do not overcomplicate it. I know it's not really that difficult. Calculation are never difficult. Now, again, where does that third derivative come from? Because the first one is they are giving us the value. The second, we need to find where the third one comes from. Often, we go back to what we were doing to see whether previous part will give me that derivative. Did I created a function there?